Hi, my name is Mario. I'm going to go over how to do a successful project proposal for Information Visualization 2018. This is the title slide, and I'm going to share this slide deck with you so that you don't have to invent a structure and a look. I don't want you to spend time there, so just copy and replace the content. Okay, so the title slide should have a title for your project, and it should have this text at the bottom so that we know what we're doing and when we're doing it. You should also put images of the members of the group. Some of you may not want to share an image of you, and that's okay. But in general, this is something that will help us when we are grading the projects. Okay, so we have images of all the members of the group, and we have contact information. Email is good contact information. The second slide should have, again, your project title and some image that has somehow inspired you to do this project. It should be a cool image, and it should take more or less the entire slide. But you go through this very quickly. This slide you're not going to have in your presentation, but it is the outline. You won't have time to talk about the outline, but I'll do it here. You're going to spend about a minute motivating the problem. Why is it important? 2 minutes motivating the goals and challenges. A minute talking about related work, and a minute talking about methods and techniques. Then you're going to spend a minute talking about the workload and distribution of the work among the group members. Again, this has to be very quick, so no time to go in depth. And we're going to leave 2 minutes to allow people to give comments, feedback, questions. I will stay quiet during this time so that you have time to give your feedback. I will give my feedback on the lecture afterwards. We have 90 minutes to present 11 projects. So that's why we need 8 minutes per project. And this means you're going to have to practice over and over and over again. When you're going to submit your projects through a link on a post that I put on the Facebook wall on Thursday evening. And the link to your Google Slide document should have this name. It's here on the left. It says EVIS18_proposal_name of project. So here you put the name of your project. You need to motivate. Why is this project interesting to you as a group? Why is this project interesting to me as the audience? What do I want to learn by doing this project? Here, when I say I mean I, the student. Why does the world need this project? It may not need the project, but you just think it's cool and you can state something like that. Or it may actually need the project very much. How does this project improve the world? Well, even little changes can be towards the positive. Keep that in mind, stay open-minded, and be ambitious. Goals and challenges. Here you have a couple minutes to talk about what you want to accomplish. And there's a difference between what the project accomplishes and what you learned through the project. Focus primarily on what you learned through the project, and what the project accomplishes is a means to the end of you learning. Remember, you are doing this to learn, even if you are working for one of our partners through one of their offers. So the goal, what does this project accomplish in the first, second, and third place? The challenges, what are the obstacles to attaining this goal? 1, 2, and 3. Related work. You're going to spend only about a minute talking about this. And it's going to be, you're going to show just images or even very short snippets of video of related works. And this should be related somehow in the literature. You could cite related work from previous years, from students' work from previous years, but that's okay. But you should be as academic and formal as possible. So formal citations are better. So here you have an opportunity to talk about similar project number 1, related work number 1, perhaps a cool video, an image demonstrating it. Say what the related work was about and how it is related to your project proposal. Again, this has to go very quickly, so you need to practice a lot. 1 or more people can present. It's up to you. Clearly state what about your project is different from this project. Clearly state why these differences matter. Only show a video or figure, no text on this slide. Memorizing everything you say, and only what you say. The next slide, slide number 9 in this case, is methods and techniques. This is probably the most important part of your presentation. Put most of your effort making sure you have researched and tested the feasibility of this proposal. You only have 1 minute to talk about this, so memorize everything you are going to say and only say that which you mean to say. Here, for example, you can talk about what methods you will use in your project, what devices you will use, what libraries will you import, how will you connect the parts, will you develop anything new that can be contributed back to the world as code or design pattern, for example. You can have a repository that you make public and other people can use. What interaction paradigms will you use? Will you design new interaction or new algorithms? You should talk about these methods and techniques on separate slides using as many visuals and video aids as possible, but again, keeping a close eye on your time. The individual contributions is also very important, and you will be graded on your individual contribution throughout the project as well. In other words, part of your grade will be a group grade, part of your grade will be individual. Therefore, the only way you can get an A in the class is if you have a strong individual contribution to the project. Therefore, it is important for you to state what each of you will be doing. Again, stay focused on the learning objectives. Practice, practice, practice your presentation. It is too short to mess up. Also, please make sure it runs in Vic. Google Docs have worked well in the past. So just put the link to the Google Doc. We're not going to have time to switch computers, so none of that. If you have a live demo that you want to run, make sure that it is running before you start your presentation. So arriving early to test that anything that you want runs is the way to go. We won't have time to test while you're presenting. Now I'm going to show you Food Advisor, one of the proposals from Information Visualization 2017, which became a very successful project. It was headed by Joaquin, Mons, Victor, Manhu, Thea, Martin, Yuri, and you. As you can see, all of them chose to put images of themselves and contact information to all of them. Here they could have summarized their email with simply stating all of them at kth.sc, and that would have made the slide a little simpler. Otherwise, it's fantastic. It has a good background. You go to the second slide and you have why it matters to us all. And this is a historical level of CO2, and here you can see how it's rising. And in fact, food is one of the main contributors to CO2 emissions. So this is a project that you would like to work on and use some of the visual structures and interactive structures and data that you have from sources such as Gapminder, which is one of the related projects and at the same time one of the motivations of this project. We want to watch the way we eat, how we eat has an impact in the environment. So for example, if you choose beef or beans to get your protein, that will have an impact in terms of carbon distribution. Can we make wiser food choices? That is the main question. Well, the goals for the users is to make users more aware of the carbon footprint of their food, educate users about sustainable choices, and create a fun platform that is encouraging to play around with. Of course, they're going to face some challenges. For example, how do they find a way to realistically represent a large range of the data types from different sources? And how to not make an intrusive device. In other words, interrupt the process of decision making when you are thinking of what to eat in terms of not just nutritional value, but also in terms of the carbon footprint that you're producing. And materialize the ideas in an elegant way that people will want to use. So what the world eats. Here is a chart from National Geographic, and you can see different countries around the world and how they're distributing their diet. Here you can see grain is brown, sugar and fat is purple, meat is red, and so on. So here's an inspiration, a related project number one. Another related project is Carbon.to from the Center for Sustainable Communication here at KTH, and what it does is it translates it translates units of energy. So for example, 10 bananas, how much is that in terms of flight kilometers? So apparently it's 9 kilometers of flight. Okay, and then they talk about the methods and the techniques. What are they going to use to manage the group, in this case Trello and Slack? And they probably also use GitHub. And what are they going to use in technical platforms to create this project? So as you can see, they're doing D3, JS, Python, so JavaScript, Excel, node crawler, JSON in the front end, and Mongo. And of course, the version control is happening at GitHub. They created a fancy matrix of individual contributions, which I encourage you to explore and study closer. And They also stated a simplified version of their individual contributions in the next few slides. And they even showed what their project may look like once it starts getting closer to a deliverable. So here you have a scatter plot in 2 dimensions where the area of the points also encodes data. You have filters on the left and that allow you to focus and get details on demand on individual food types in terms of their nutrients. You can also get a map of the locations where this food is either produced or eaten, and seasonal information about how this particular product is harvested. A thank you slide again with contact information, my information as the teacher of the course as well, and some extra slides about questions. You're welcome to put extra slides that may answer, or you may think that will answer the questions that your audience may have. Again, practicing this in front of each other will allow you to come up with those types of questions. Now I want to show you the project actually running. And some of you have been asking, where do I get inspiration and what do previous year's projects look like? So I'm at the social page for information visualization. The address is social/course/DH2321, or you can also Google Infovis KTH and you will get it, or information visualization or IVIS. Anyway, so this is our social page, and I've given the link to it a number of times. And here on the left, you have 3 links called SEO Awards 2015 through 17. I've been meaning to add 14 and 13 projects and the ones from 2012 that I still have. I will be doing that as soon as possible. Regardless, I think you have enough information to get inspiration. So here at the SEO Awards 2017, you have a number of projects. Here are the projects from information visualization. In 2016, again, you also have a number of projects, and here are the projects from information visualization, but we also have projects from advanced graphics and interaction and from multimodal interaction and interfaces. Some of these were winners, and you can take a closer look at the winners as well. Going back to 2017, we see that Food Advisor is the first project that we can take a look at. And if we go there, you will see that we have an interactive visual structure. So let's take a quick look. What's going on here? Well, apparently we have different bubbles of different colors, and I can hover over and get some details on demand. For example, this is bacon, and down here it's beef. Here on the x-axis I have carbon footprint, and on the y-axis I have energy. So in terms of calories. Now, what if I want to take on the bubble size is also carbon footprint, so it's doubly encoded. So what if I want the bubble size to be, let's say, protein? So now I'm looking at calories, protein, and carbon footprint. So I want to focus my search a little bit, but perhaps the first thing I want to do is select a filter, and I'm going to focus on high protein food. So I will remove some of the low protein, so I want to stay high, and I want to see what this is. Well, that's peanut butter right there. So it has a lot of energy and not as high carbon footprint as you can see over here. So again, perhaps I want to see protein a little bit closer. So I'll put protein here, and I'll make this axis energy. That is the size of the bubble. So, oh, this is much better. So now I will zoom here in this range right here. Yes. And you can see that beef is over here, and it has 21.69 grams of protein per 100 grams of serving. But we have foods over here like dried beans that have even more protein than beef, but their carbon footprint is much lower, 0.7 carbon 2 emissions versus 22.7. I have to review what the units are here. All right, so that's interesting. Furthermore, I have this very high protein food over here called cured ham that still has 10 times more carbon footprint than dried beans. Well, that's interesting. All right. Perhaps I can focus even more on, I'll leave peanut butter there, and I will remove fruits. Maybe I leave cheese there. I remove sweets, root vegetables. They're out of the picture anyway because of the filter that I created here. I'll remove vegetables. If I remove legumes, of course, I lose this great source of protein. And I will keep fish, grains, and I'll remove drinks. What is this drink? This is tea, interesting, and coffee. Okay. Unbrewed. So if you eat the beans, I guess. All right, so I'll just leave that out and leave the rest here. What is the difference between legumes and grains? Well, oh, sorry, this is grains, this is cheese. So grains are no longer in the picture either, so I'll just take that out. Okay. So you've seen I'm able to, for example, get details on demand on dried beans. And here we have macronutrients like carbohydrates, protein, fiber, water, monosaccharides, fat, disaccharides, sucrose, and salt. Or I can go to micronutrients over here. And I got potassium, folate acid, phosphorus, magnesium. These are micronutrients because we're measuring this stuff in milligrams. Whereas over here we're measuring